A manufacturer of circuit boards has a stock of 200 resistors, 120 transistors, and 150 capacitors, and is required to produce two types of circuits. Type A requires 20 resistors, 10 transistors, and 10 capacitors. Type B requires 10 resistors, 20 transistors, and 30 capacitors. If the profit on type A circuits is $5 and that on type B circuits is $12, formulate a linear programming problem to maximize profits. So in this tutorial, we're going to formulate a linear programming problem to maximize profits given that information. And to do that formulation, I'll start by looking at on the variables. What is it which is varying in the information that we are given there? What we are having is the number of type A circuits and the number of type B circuits are varying there. Because we can change the number of type A circuits, the number of type B circuits to suit what we want. So those will be the variables. So we have the number of type A circuits, that's the first variable, and I'll call it X. And then the number of type B circuits, I'll call it Y. So those are the two variables for this problem, X and Y. After defining the variables, I now go on and look at the objective of the problem. What we are being asked here is to maximize profits. So our objective is to maximize profits, but we are told that the profit on type A circuits is $5. If the profit on a type A circuit is $5 and we are making X type A circuits, then the profit from the type A circuits will be 5 times X, because we are making $5 profit on each type A circuit. And if we are making $12 profit on type B circuits and we are making Y of them, and the profit there will be 12 times Y, because we are making $12 for each type B circuits. Therefore, the profit there will be 12Y for the type B circuits. And to combine the profit, will be adding the profit of the type A circuits and the profit of type B circuits. So our objective function will be maximize set, which is equal to 5x plus 12y. And that will give us the total profit. Now moving on to the constraints. We cannot make as many circuits as we want just because there are some limitations. There are limitations on the number of resistors, transistors, and capacitors that are available. So those will be our constraints. So in this case, what I'm saying is the constraints there are the resistors, which we have 200, the transistors, we have 120, and the capacitors, we have 150. So we are having that the constraints are the number of resistors, transistors, and capacitors. So I now go on and try to put that information in a table so that we see it clearly. So I will draw a table and write the type A circuits and the type B circuits. Then we have the resistors, and the resistors we are having 200 of them. And for the transistors, we are having 120. And for the capacitors, we are having 150. Now I go on and look at the type A circuits. The type A circuits, they require 20 resistors. So I'll write the 20 there in the table. And they require 10 transistors. And then I'll put a 10 there for the transistors for type A, 10 capacitors, and I'll write down the 10 there for the capacitors. Now moving on to the type B circuits. For the resistors, they require 10 resistors. So I'll write down the 10. And they require 20 transistors. So I'll write the 20 there. And 30 capacitors. So I'll write the 30 there. We now have the information in a table. So I can now go on and try to analyze what we are looking at. For the first one, we are looking at the resistors. And there are 200 of them. And we are looking at type A circuits. They require 20 resistors. So if we are making the number of type A circuits to be X, and then the total number of resistors that will be used to make type A circuits will be 20 times X. Because each type A circuit is requiring 20 resistors, and you are making X of them, so it will be 20X, the amount of resistors used by type A circuits. And for the type B circuits, each circuit requires 10 resistors. And if we are making the number of type B circuits to be Y, then the total number of resistors used to make type B circuits will be 10 times Y. So when you add this total, the number of resistors used to make type A and type B circuits, they should not exceed that 200 there, which is on the right. And if we write it in mathematical form, not exceeding 200 is less than or equals to. So we would have the first constraint there would be 20x plus 10y less than or equals to 200. I now move on to the second one there. The transistors, we are having 120 of them. Type A requires 10 transistors for each circuit. So if we are requiring 10 transistors for each type A circuit, the total number which will be used to make type A circuits will be 10 times x. And the total number which will be used to make type B circuits will be 20 times x. When we add those transistors, they should not exceed 120. So in mathematical form, it will give us 10x plus 20y less than or equals to 120. And next, we look at the capacitors. We are having 150. And each type A circuit requires 10 capacitors. And if we are making x number of type A circuits, the total number of capacitors that will be used will be 10 times x. And if we are making Y type B circuits, each circuit using 30 capacitors, the total capacitors used to make type B circuits will be 30 times Y. And the total number of capacitors used will be the 10x plus 30y. And this total must not exceed the 150 which is available. So when you write it as a constraint there, it will be 10x plus 30y less than or equals to 150. So we are done with the constraints which are in the table there. But there is one more constraint that we should consider. We are counting here. These are number of physical things. A number of type A circuits is x. Number of type B circuits is y. When we are counting physical things, we don't go to the negatives. So to make sure that the x and y are non-negative, we have to write the constraint that x and y are greater than or equals to 0. So what we have now, we have written the objective function. We have our constraints there. So our linear programming problem is maximize z, which is equals to 5x plus 12y, subject to 20x plus 10y less than or equals to 200, 10x plus 20y less than or equals to 120, 10x plus 30y less than or equals to 150, and x and y greater than or equals to 0. So that's the linear programming problem that we were required to formulate.